Let's jump right in. If you're a project manager, a data lead, or honestly anyone tasked with managing massive data sets, you already know the struggle. Human annotators are meticulous, sure, but labeling just a single hour of complex video, that can literally take hundreds of hours of manual labor. You're constantly balancing this need for highly accurate computer vision training data against, tight budgets and strict deadlines. So today, our goal is highly specific. We're going to evaluate object tracking models that not only solve those really tricky computer vision challenges, but actually reduce your overall project costs and accelerate scalable workflows. We're moving way beyond the basics here to look at the exact tools driving real-world automated data labeling efficiency. Okay, let's dive into this. Here's our roadmap for today. First, we'll look at scaling automated data labeling. Then, we'll compare object detection versus tracking. After that, we'll evaluate some key tracking algorithms. Fourth, we'll talk about overcoming common visual occlusions. And finally, we'll wrap up with the basic AI workflow for productivity. All right, Section 1, Scaling Automated Data Labeling, the business case for efficiency. So let's frame the business problem right out of the gate. Manual data annotation in large-scale industrial projects is incredibly costly. And quite frankly, it's just too slow for modern demands. Moving from basic motion detection to sophisticated AI-driven tracking systems, well, that's no longer just a nice-to-have. It is an absolutely crucial necessity to maintain your competitive edge. Because relying purely on human annotators for every single frame of a high-def video, yeah, that's a surefire way to drain your project's budget. Automation is absolutely the key here. To put that into perspective, processing vast amounts of big data using tracking algorithms translates directly into actionable ROI across a ton of different sectors. Take retail analytics, for example. Tracking customer foot traffic helps optimize store layouts, which directly boosts sales. In smart cities, it's about processing hours and hours of traffic footage to fix congestion and pinpoint accident hotspots. Or in the IoT and smart home space, it's about fusing cameras with sensors to actually differentiate known residents from unknown individuals. In all these cases, automated tracking is the engine, turning raw, massive video data into highly valuable, structured insights, and doing it without breaking the bank on manual labor. Moving on to Section 2, Object Detection versus Tracking. Understanding the technical differences. Before we can fully automate our workflows, we absolutely must understand the distinct tools in our pipeline. Now, what's really interesting about this is the technical contrast. Object detection is fundamentally a one-off process. It looks at a single static frame, finds predefined classes, like cars or people, and categorizes them. It's an isolated event. Object tracking, on the other hand, takes that initial detection and adds the dimension of time. It focuses on the temporal component, basically monitoring an object's continuous movement and trajectory across successive video frames. And this continuous temporal link is exactly why tracking is the true engine of workflow automation. While detection answers the what and the where, tracking answers where is it going. Crucially, it maintains the identity of an object even when it's temporarily obscured. Because it creates a continuous process from that initial detection, tracking is what actually enables the real-time interpretation of dynamic, real-world visual data. If you want a truly scalable industrial workflow, you absolutely need systems that understand continuous trajectory, not just static snapshots. Okay, Section 3, Evaluating Key Tracking Algorithms. Let's open up the Deep Learning Toolkit. This is where we get into the core evaluation for project managers looking to really optimize labeling efficiency. First up, we have Deep Sort. Now, Deep Sort takes a standard tracking algorithm and basically supercharges it with a deep learning feature extractor. It combines this deep learning, which is fantastic at differentiating between objects, with a Kalman filter. And a Kalman filter is essentially a mathematical algorithm used to predict an object's future movement based entirely on its past trajectory. Because of this powerful combo, Deep Sort is totally your go-to choice for multi-object tracking scenarios. Think crowd monitoring or really busy traffic intersections, where distinguishing between a bunch of similar objects is absolutely critical. Next up, we have MDNet, or Multi-Domain Network. So what makes MDNet stand out? Honestly, it's the incredible adaptability. It's trained on multiple different video sequences, which gives it a highly generalized understanding of varying scenes. It uses domain-specific neural network layers and features real-time online learning. What this means in practice is the model actually fine-tunes itself on the fly, right there, based on the specific characteristics of the object it's tracking in that exact moment. If your project involves highly diverse scenes where objects undergo significant appearance changes, like, say, moving from bright glaring light to deep shadow, MDNet is a remarkably robust choice. Finally, let's look at SciMask. Most traditional trackers rely on bounding boxes, literally just drawing a rectangle around the object, while SciMask goes way further than that. It provides pixel-level object tracking by generating a precise segmentation mask, meaning it outlines the exact shape and size of the object as it moves. So for projects requiring highly detailed spatial understanding, think augmented reality applications, really precise medical imaging analysis, or video editing tasks where you need those exact outlines, SciMask is definitely the tool you need in your pipeline. So the crucial point for a project manager here is this. Choosing the right model directly reduces your overall project costs. Think about it. If you use SciMask for a simple traffic counting project, you're literally wasting computational resources. Conversely, if you use a simple bounding box tracker for an AR project, your accuracy will absolutely plummet, leading to some really costly manual rework. Understanding these specific technical benefits, DeepSort for multi-object motion prediction, MDNet for adaptable online learning, and SciMask for pixel-perfect segmentation, that is what allows you to align your tech with your specific project requirements, ensuring a workflow that is both scalable and cost-effective. Section 4. Overcoming common visual occlusions. It's time to stress test these models. Visual occlusion, which is when an object disappears behind another object or a barrier, is hands down the absolute bane of computer vision tracking. It's the quickest way to lose a tracking identity and completely ruin a dataset. But this brilliantly illustrates exactly how our three models tackle this exact problem. DeepSort relies on its deep learning feature extraction. So even if two people cross paths and obscure each other, DeepSort remembers their unique visual features to re-identify them instantly. MDNet combats occlusion by fine-tuning in real time. If a car drives behind a tree and comes out looking darker because it's in the shade, MDNet has already adapted to that appearance change on the fly. And SciMask, it actually manages to maintain its real-time performance even during really complex motions and partial occlusions, holding on to that precise pixel-level shape without dropping the track. All right, our final section, Section 5, the basic AI workflow for productivity, moving from theory to application. Now, theoretical algorithms are fascinating, sure, but as project managers, you need practical applications. Implementing these tracking models inside a dedicated platform, like the Basic AI Cloud platform, is what actually speeds up your data labeling workflows. By integrating these advanced tracking algorithms directly into the annotation toolset, you slash manual annotation costs. You aren't just reading about AI, you are actively applying it directly to your operational pipeline to drive massive, measurable ROI. Let's move to and see how this builds into a highly practical, 5-step workflow, proving just how accessible and cost-saving this toolset really is. Step 1. Data upload. Just select your local files, URLs, or cloud data. Step 2. Set ontology. This is where you define your project's rules, categories, and attributes. Step 3. Annotate a single frame. You just use a 3D cuboid on your target object in exactly the first frame. Step 4. Auto-tracking. And this is where the magic happens. You click, and the algorithms take over, automatically annotating the object across all subsequent frames. And finally, Step 5, save and export. What used to literally take hours of frame-by-frame labeling is now a process of seconds. We've covered the business imperative of automated labeling, the crucial difference between detection and continuous tracking, and the specific strengths of DeepSort, MDNet, and SciMask. We've also seen how to deploy these directly into a scalable workflow. So I want to leave you with this provocative thought to consider. Based on the unique challenges of your data, the occlusions you face, and the precise outlines you require, which tracking model will drive your next project's efficiency? Thank you for joining me for this explainer, and I really look forward to seeing how you apply these strategies to your own automated workflows.